Alrighty, problem number 4. This looks strangely familiar. I believe it looks like the example and a homework problem, except I'm having you in this problem. So you guys can pause it and read this blurb up here, but we already know what type of problem this is. This is a right triangle with similarity, and they've already included the good 12 and the good 3. They want to know what the length of AB is. When we did this problem, we were focusing on the length of dB. We turned this into an AS problem, looking with the altitude and then our two segments here and here. All right. What's neat about this is we could solve this as an AS problem. We could get to the length of AB by finding that altitude. Because if you were to find the altitude, and I have a sneaking suspicion that it's 4, I think the altitude's 4, let's pretend the altitude's 4, okay? Maybe it isn't. You have a right triangle here. And you know one leg is 3, another leg is 4, therefore your hypotenuse must be 5, okay? So, yes, I know I've said when starting up these problems, you look at the big right triangle and you identify this as the hypotenuse. All right, that's just to have access to the AS and shell theorems, okay? But realize you also have, a small right triangle here you can use the Pythagorean theorem on. You have another right triangle here where you can use the Pythagorean theorem on, all right? You have that freedom. So if you want to do it using AS, go ahead. You'll end it with the Pythagorean theorem. I'm going to do it using another method, I think. And we'll see. My hypotenuse is going to be this 12 plus that 3, which is 15, okay? And these are my legs. I'll call that leg 1, and I'll call this leg 2. Then this must be segment 1, and this must be segment 2, with this being my altitude. And they want to know what's the length of AB. What's the length of leg 1? So I'll call that X. This turns out to be another shell problem, or I can use shell. Segment 1 is 3. My hypotenuse is 15. And then my two leg 1s, right? This is shell 1, are X and X. So when I do this multiplication, I'm going to get 45 equals X squared. I'm going to unsquare by square rooting, okay? And then I want to put this in simplest radical form, if possible. So let's see here. 45. If I were to break that up into a product, right? I've got X equals radical 45. I need one of them to be a perfect square. Well, it's definitely going to have to be a multiple of 5, okay? And 5, why isn't this writing? Sorry, a little snafu here. Here we go. Not writing. Okay, I'll have to do this using the mouse. Sorry about that. So 5 is not a perfect square, right? So we're definitely going to have, where's my mouse? We're definitely going to have radical 5, okay? And then the other thing we're going to have is radical 9, right? 9 times 5. Let me do it in my hands here. 9 times 5. Yeah, that's 45. So when I go to simplify that, the square root of 9 is 3. And I can't do the square root of 5, so I just leave it. All right? So it turns out the length of AB is 3 radical 5. All right? Sorry about that.